All right, hello students. Today we're moving on with lesson 8, replacing numbers with letters. So today we're going to talk about a few different properties that we need to know kind of moving forward in this unit. So if we look at the opening exercises, we have a few different equations going on here. We have 4 plus 0 is 4, 4 times 1 is 4, 4 divided by 1 is 4, 4 times 0 is 0, and 1 divided by 4 is 1/4. So remember, this fraction bar is another way of kind of writing division. All right, so if we kind of go through and answer the questions, how many of these statements are true? Well, if we kind of look at them, we kind of evaluate them. If we look at them, well, how many are true? Well, all of them are true. All of these are true statements. Not one of them is false. Um, you might think to yourself, well, aren't all um, statements true dealing with numbers and dealing with numbers? And the answer is no. As you can see, as we kind of go through this, we're going to kind of run into a couple situations where it won't be true. Well, let's go ahead and look into the second part. It says, how many of those statements would be true if the number 4 was replaced with a number 7 in each of the numbers sentence? So what happens if we rewrote all of these, and instead of having a 4, we simply had a 7? So if I went 7 plus 0 equals, well, there's a 4, so I replace it with 7. Would that be true? And the answer is yes. Multiply 7 times 1 because replacing the 4 equals 7. Yep, that answer is true as well. 4 divided by 1. Oh, sorry, not 4. Oops, forgot to replace it with 7. I apologize. Remember, we got to replace it with 7. Let's go and get my pen back out. 7 divided by 1 equals 7. Is that true? The answer is yes. 7 times 0 equals 0. So I'm not replacing the 0, bringing it over. And then 1 divided by 7 equals 1/7. And of course, hopefully you recognize that yes, all of these are true. So just like the 4, just because we changed the number, it's changed the number from 7 to 4 to 7. Does that make any of these false or not true? And the answer is no. All are true. So once again, all of these statements are true. Well, if we continue kind of going through this and we look at the next part, well, I'm going to change slides. You'll be on the same slide. I brought this over because we're going to need this. Well, what if we changed it? What if I said, what if we replace 4 now with 0? So what if we go ahead and replace all the 4s with 0? Will this change our statement? Well, if I went 0 plus 0, does that equal 0? Well, yeah, that's true. That works. 0 times 1, does that equal 0? And the answer is yes, that's true as well. 0 divided by 1, well, that still equals 0. So far, everything's the same. Last couple, 0 times 0. I have 0 groups of 0 in it, so yes, that's 0. And the last one, 1 divided by 0, does it equal 1/0? All right, here we go. This right here is not true. You can't divide a number by 0, so 1 cannot be divided by 0. You can't take 1 and cut it into 0 pieces. That's what it's saying. Remember, when you're dividing, you're doing some breaking up. So here, this statement is not true. You can't divide a number by 0. So the question is, would each of these number sentences be true? And the answer is no. So let's go ahead and get our text box out. Let's go ahead and write a little statement. So would each of these be true? And the answer is no. And we kind of get into a little bit more, I guess, detailed. No, the first 4 sentences, let's go and put sentences because they're not expressions. Oops. Let's go ahead and do a quick change. Sentences are true, but the last one is not. All right, so remember, division is you're breaking it up into pieces or into 0 pieces. You can't break 1 up into 0 pieces. That just doesn't work. That doesn't make any sense. So actually, we call this undefined. You kind of learn about that more when you get to the 8th grade. Well, the last statement or last part here, it says, What if we replace the 4 with a G? So now we're going to replace the number with a letter. Please write all 4 expressions below, replacing each 4 with the G. Well, you can write it here if you want to. I'm going to write it over here on the side because this is kind of the other room we had and kind of looking at all of them. Well, if we just simply wrote G plus 0, does that equal G? Well, yeah, anything plus 0 equals the anything. So it doesn't matter what number we put in here for G, it's true. Well, if we went G times 1, does that equal G? And the answer is yeah. Anything times 1 gives you the anything, or G times 1 gives you G. Well, let's do another one. G divided by 1, does that give you G? Yeah, anything divided by 1 is the anything. It's kind of very similar to the multiplication, with the exception, that one is fine, even with 0. The next one, we have G times 0. Well, anything times 0 is 0. So, yeah, it doesn't matter what G is. It gives you 0. And the last one, if I have 1 divided by G, does that equal 1 over G? Well, this one right here, so all 4 of these top ones are true, kind of similar to the first one. Well, this last one has an exception. So let's get a different color. So only exception to the rule, I'm just going to put EXP for exception, is that G cannot equal 0. As long as G doesn't equal 0, this last statement is true. But once you kind of get G to equal 0, well, then you have this situation. You can't divide by 0. So we took a moment, we did the rewriting. Now let's go ahead and look at the question here. It says, are all these true except G equals 0 when dividing? So here we go again. So they're kind of telling us here, I don't know why I put a P there. I guess I should have erased that. I apologize. As long as G is anything but 0, this statement is true. So let's go ahead and write out, are all these statements true? Yes, as long as G does not equal 0. And that's what it says here. All right, so that's kind of getting us into kind of talking about the different operations and kind of changing numbers with letters and seeing kind of what's happening. So that's going to help us kind of as we get into the next part. So go ahead and stop the video, go ahead and move on to the next. All right, hello students. Today we're moving on. We're going to move on, to example number 1, the additive identity property of 0. So if we look down here, it gives us kind of the example, or one of the examples we had kind of in the opening exercise, where 0 or G plus 0 equals G. So we kind of look at the first part and kind of discuss what the additive identity property of 0 actually means. If we look at the first part, it says remember a letter in a letter in a mathematical expression represents a number. So this G here represents a number, any number. Can we replace G with any number? Well, the answer is yes, we can. We can replace G with any number. Well, now we're going to go ahead and we're going to choose a number and we're going to replace it to see if it actually works. Well, let's go ahead and choose a value for G and replace G with the number in the equation. What do you observe? Well, we go ahead and choose any number you want to. You can go ahead and pick any number you want to think about, but I'm going to go ahead and choose 2. I'm going to let G equal 2. All right, so if I plug that in, if I put 2 plus 0, does that still equal 2? And hopefully the answer is yes, it does. This works. So what do I observe here? Well, what I observe here is the fact that when I add 0 to something, it doesn't change the value. So what do I observe? The value of G, in this case 2, does not change when 0 is added. So whenever I have any kind of G, no matter what it is, if I add 0 to it, it doesn't change. Now the second part says repeat the process several times, each choosing a different number for G. So if you want to, you can try to pick a number for G and add it to 0, and you'll see that this will never change. Whatever G is, if you add to 0, is the answer as well on the other side of the equation. So we're just going to kind of skip this part right here. If you wanted to, you could do it, but um, we've kind of gone over several problems already like that. So we're just going to go and continue moving on. And then it says, will all values of G result in a true number statement? And the answer is yes. Okay, kind of like we said up here, we kind of thought about it. The answer was yes. And of course, we kind of find out through this trial and error that the answer is yes. Now it says write the mathematical language for this property below. So now they want us to write a little statement talking about the additive identity property of 0. So if we say G, let's go make it lower. Oops. G plus 0 equals G. So this statement is true because, or the statement is the additive identity property. Oops, of 0. It says any number or added to 0 equals itself. So whenever you add a number to 0, nothing changes. The answer is the number itself. And that's what kind of these variables represent, or the G in this case represents. If I add anything to G, nothing changes. It's still just G. All right, so this is a property we need to remember. We need to keep in mind the additive identity property of 0. All right, so go ahead and stop the video. We're going to move on to our next property. All right, hello students. Now we're going to move on to example 2, kind of the next property we're going to talk about. It's called the multiplicative identity property of 1. So before we talked about the additive identity property, now we're talking about the multiplicative identity property of 1. Because remember, just like when you add something to 0, nothing changes. Here, when you multiply something by 1, does it change? Of course, the answer hopefully is no. So we're going to kind of go through the same basic steps that we talked about with example 1, but now we're going to do with this one. So remember, a letter in a mathematical expression represents a number. So once again, G represents some number. Can we replace G with any number? Well, once again, hopefully we know that if I replace G with any number, the answer is yes. We can replace it with any number and this statement will still be true. So once again, we're going to choose a value for G and replace it in the equation. And then notice what we observe. So let's go ahead and pick any number for G. Let's go ahead and let G equal, in this case, let's go and let's make it equal 8. So the question is, if I plug in 8 times 1, does that still equal 8? And hopefully you notice that this is yes, that is true. So what do we observe? Well, hopefully observe whenever you multiply any number by 1, the answer is the any number. So what we observe is the value, very similar to the other one, the value of G does not change when G, is multiplied by 1. So just like before with the adding of 0, when you multiply any number by 1, it's just simply the any number, whether it's 8, 9, 10, like before we could do multiple ones. It's all the same. We've done this several times now, and hopefully you've seen this in elementary school plenty of times. So there you go. All right, so let's go and look at the next part. It says, will all values of G result in a true statement? Excuse me. Once again, experiment with different values. So kind of like we said before, we could try different values. If we did it with 7, we did it with 4, we did it with 2, with G, So once again, we could try any number. If you want to, go ahead and take a moment and try some different numbers, see if it makes sense. Even use a calculator. But of course, you'll see that the answer is yes. All right, and the last part, just like before, says write a mathematical language of this property. So once again, mathematical language, G, oops, I don't know why it keeps capitalizing, times 1 equals G. Well, this is called the multiplicative property of 1. This is a property that you're going to have to know, be able to identify. And of course, what does this mean? This means that any number multiplied by 1 equals itself. So once again, when it equals itself, it just simply means it does not change. So once again, you multiply any number by 1, the answer is just simply itself. All right, going to stop the video, go move on to the next one. We'll talk about our final property of this lesson. All right, hello students. Now we're going to move on to a kind of our final property or properties. Is actually kind of two in one. It's called a commutative property. More specifically, it's a commutative property of addition and the commutative property of multiplication. So it's kind of a similar property, just with two different operations. So this is the kind of the property, or what it looks like. It says 3 plus 4 equals 4 plus 3. Well, the answer over here is 7. The answer over here is 7. It doesn't matter how we add these together. Well, the same thing is true with multiplication. 3 times 4 equals 4 times 3. Once again, it doesn't matter how you multiply these. Both of these equal 12. Well, if we kind of take our time and go through this kind of step by step and discuss this, let's go through kind of some steps and changes into an algebraic form, or kind of replacing numbers with letters. So replace the 3's in the number of sentences with the letter A. So let's go ahead and get our pen. So all we're going to do is simply take our 3. So every time we see a 3, we're going to plug in an A. So A plus 4 equals 4 plus A. And if I do the same thing on the other one, of the multiplication, A times 4 equals 4 times A. Now, usually we wouldn't use the X with a multiplication problem, but just to kind of keep this kind of looking similar, we're going to use the X just to show our multiplication. But usually when we use variables, we would not use this X to show multiplication. So if we take, we just simply did the replacement. The second part says, choose a value for A and replace A with a number in the equation. So if we choose any kind of value for A, would the statement be true? Well, if we kind of just do it mentally, we don't really kind of need to write anything out. If we just simply start thinking about it, well, if I plug in 2 here, is 2 plus 4 is 6, is 4 plus 2 is 6? The answer is yes. If I plug in 2 here, 2 times 4 is 8, is 4 times 2 8? Yeah, the answer is yes, it's true. And so if we continue to do this, we can do it. Let's go and do it one more time. Let's go and place A with 5. If I went 5 plus 4 is 9, 4 plus 5 is still 9. And once again, 5 times 4 is 20, 20 times 5, sorry, 4 times 5, excuse me, is still 20. All right, so we could do this over and over again, but we should see something being true. The result is, or no matter what we place with, the result is still the same. The result is still true. So once again, no matter what number we replace A with, the result or the answer is still true. So let's go and write that down. No matter what number we replace, right, because that's what they asked us to do, A with the result, right, is a true sentence. So it's still a true sentence no matter what happens, no matter what number we plug in for A, whether it's the top one or the bottom one. All right, so let's go and continue on to the next part. It says, will all values of A result in a true statement? Experiment with different values. So we kind of did that already. We kind of took the time and did kind of different values. So is there a number we can place in there? Well, 0 usually is kind of the problem. Let's kind of look at 0. 0 plus 4 is 4. 4 plus 0 is still 0. 0 times 4 is 0. 4 times 0 is still 0. So yeah, all numbers that you plug in for A would result in a true statement. So once again, you could experiment with different numbers. You can even use a calculator to help you. But any number, I like to even emphasize, even 0 can be used in place of A, in place, of the variable. Let's go ahead and kind of use some more vocabulary. In place of the variable, let's go ahead and use that. I like that idea. Variable, oops, B not V, A. So no matter what number you plug in, this is what we like in math. We like things that don't change. We shouldn't have, things don't change a whole lot in math. They should be kind of staying consistent throughout the problems. That's what makes it math. All right, it says now write an equation again. This time replace the 4's with b. So we remember, you can kind of look back at the other one, but I have a plus 4. Well, in this table we're going to put b, and that equals b comes first, plus a. Well, same thing with multiplication. I have a times 4 up there, so this is a times b. Once again, we're just using the x for this example, and then b times a. So now it says, if we look kind of the next part, it says, will all values of a result in a true statement for the two equations? Experiment with some different values. So once again, what we kind of do is more verbally. I'm not going to kind of write out a whole bunch of different examples. Let's go ahead and look at this verbally. Oops, moved that on accident. I meant to put a text box in. But if you kind of plug in any different numbers, if you want to, please pause the video and plug in different numbers. If I make a 2 and b 1, well, 2 plus 1 is 3, and 1 plus 2 is still 3. 2 times 1 is 2, and 1 times 2 is still 2. So can you think of anything that doesn't work? And to be honest with you, I can't. So the question is, will all values of a and b result in is a true number sentence? And the answer is yes. No matter what number, actually let's go ahead and add that in there. No matter what number we replace a or b with, will result, let me get my cursor out of the way, in a true number sentence. I'm just going to expand this out a little bit. I'm starting to run out of some room. There you go. All right, so no matter what we replace it with, it will result in a true number sentence. Let's go and just drag that out, kind of put those together. All right, so the last part now says, write a mathematical language for this property. So now we have to kind of write this in mathematical language, very similar to what we did before. Well, this time we have 2 of them, so let's go ahead and do one at a time. So first we have a plus b. I don't like it when it does that. Plus b equals a plus b. And this is called the commutative property of addition. Of course, commutative property means, this means order does not, oops, that wasn't very good, does not matter when adding. So it doesn't matter what order in which you add them, it just always will give you the correct answer. That's why B and A are switched here. And we kind of do the same thing with our other one. Let's go ahead and look at this kind of the same thing, but now dealing with multiplication. What happened to my text box? There it is. All right, if I go A, let me extend this out. I don't like it when it does that. There you go. A times B equals B, cursor out of the way, times A. This is called the commutative, property of, now instead of addition, this is now multiplication. And just like before, oops, let's go and replace that real quick. Just like with addition, when commutative property talks about order, does not matter. I did it again. See, it does not matter when, and now we're talking about, let's see if I can expand this out a little bit. Oh, I just scooted it over. And of course, we're talking about multiplying. I guess it's all right that it's down there. All right, so whenever you're multiplying, it's not okay that I didn't spell it right though. Let's go and just change that real quick. When you're adding or multiplying, order, remember, does not matter. It doesn't matter which order you multiply them. All that matters is what numbers you're actually multiplying together. Whether it's 2 times 3 or 3 times 2, order doesn't matter. All right. So that's the last property, and this one you're going to see quite often, the commutative properties. So that's one you really need to remember moving forward. All right, so go ahead and stop the video and go